Hello, my name is Swaiba, and this is the video for my dissertation project. Observing video games in the past 2 decades reveals, among other things, the recurring addition of a particular simulation, the pendulum swing. With this in mind, this research project aims to answer the questions on screen. After exploration of the literature surrounding the topic shown on screen, a simulation of the simple pendulum was created in adherence with object-oriented and user-centered design principles. The simulation is force-based, using the following equation to calculate the net force required to move the bob along the pendulum arc. All functionality for this simulation is contained within these 2 scripts. To demonstrate its flexibility, 2 scenes containing 2 different implementations of the simulation have been created. The swing from start scene and its corresponding interface showcase the simulation running in a constrained environment along 2 axes. Notably, the amplitude of the bob does decrease after about 60 seconds into the simulation. The playground scene demonstrates the simulation working with a force-based character controller and a dynamic target detection script. As shown on screen, the player can swing at various speeds, across different axes, and in a variety of different contexts. Overall, the project was mostly successful in simulating the simple pendulum. In order for it to be called completely successful, specialized research into real-time physics engines needs to take place to understand exactly what is causing issues with the amplitude decreasing over time, and to come to a relevant solution. Regarding the second research question, the project has been moderately successful in achieving modularity and usability within the simulation. The use of the simulation by 2 different interfaces and in 2 different scenes shows its ability to be integrated into other projects. While the inspector has been extended and displayed in accordance with user-centered design principles, such as the Gestalt proximity principle and the visibility principle, it is arguably lacking in other aspects. For example, it is not entirely clear when variables are being used in the simulation and when they are not, as with the start jump force and the custom time step. In hindsight, adding some form of progressive disclosure, such as graying out the variables when they are not being used in the simulation, would have been an adequate way to solve this issue. Recommendations for further work include research into real-time physics, as discussed, and user testing to understand exactly how the aforementioned issues affect user experience.